virtual local area networks. You'll recall that by default, all ports attached to a layer 2 switch operate within the same broadcast domain, which means that if device A attached to port 1 on a particular switch sends a frame that's a broadcast, that frame would be copied to all other devices attached to any other ports on that switch. This is a layer 2 limitation. However, with VLANs, virtual local area networks, we're able to actually segment that same switch to operate like multiple layer 2 bridges. So therefore, VLANs provide us with segmentation, flexibility, and security. Note here on switch A, we've assigned 3 ports to the red VLAN. By the way, we generally use colors to differentiate between the different VLANs. So here we have 3 ports in the red VLAN, 3 ports in the black VLAN, 3 in the green VLAN, all identified on switch A. It's important to note that each VLAN is its own broadcast domain. It's also important to note that each VLAN or broadcast domain should be directly associated with a separate logical subnet. So here we have the red VLAN, black VLAN, and the green VLAN specified on switch A. Over here on switch B, note that we can have the same VLAN identified on a different switch. The red VLAN over here, the black VLAN, and the green VLAN. 3 ports are assigned to each of those VLANs respectively. If a broadcast is sent out by a device attached to a port that's in the red VLAN, the only other devices that would receive that broadcast would be those that are in the red VLAN. Other devices in the black VLAN or green VLAN would not receive that broadcast and so therefore not have to take up processor time on the respective devices. Each of these links or ports are referred to as access links. An access link is a link or port that's assigned to one VLAN. So each of these are access links in the red VLAN, in the black VLAN, and in the green VLAN. You have access links on switch B as well in each one of those VLANs. If we put an access link between switch A and switch B, a red access link between those, devices in the red VLAN on switch A could communicate with devices on switch B in the red VLAN across that red access link which is configured between the switches. However, the limitation still is that the black VLAN devices would not be able to communicate across from switch A to switch B, nor would we be able to communicate between the green VLAN and green VLAN on switch A and switch B. So therefore, instead of using an access link between the switches, we use what's called a trunk link. A trunk link is capable of carrying multiple VLANs. So you could have some red VLAN traffic going across, you have black VLAN traffic going across, as well as green VLAN traffic going across that same trunk link. So the access link carries one VLAN at a time, and then the trunk links carry multiple VLANs. Now, how do these links become members of a particular VLAN? This is called VLAN membership. There are 2 ways that this can take place. One is with static VLAN membership. This is where the administrator assigns a particular VLAN to a particular port. So port